姐在喊礼品，姐在外边。
Shengi, do you want me to share my screen or how are we going to do this? You're on mute.
Your share your screen.
Okay.
Yeah, I think let's start. So good morning, everyone. Welcome back. So yesterday I shared the DaySim some information about the DaySim update project at a high level. And as I mentioned yesterday, so we're going to invite our Dr. Mark Bradley and Nagandra Darkar to share what they did in more detail. So Mark, yes, please start your presentation.
Okay. This is going to be kind of a shorter version of a presentation I gave to SACOG back about a month ago, and Nagendra will be I'll be going into a little bit less detail than I did during that one, and then Nagendra will be going into more detail on the calibration steps, which I think will be useful to a lot of you. So this project involved okay. Now I think you can hear me again. So it involved updating the SACSIM, the DaySim models that are sort of the core of SACSIM based on the 2018 household travel survey data. Based on what we had learned since that survey, we redid some of the data processing for modeling. We put in a new model into DaySim in this project, which was for people who don't work at home all the time, but choose to telecommute some of the time. So work at home some days, or actually during the pandemic, a lot of people have been working at home all the time, even though they do have another office that they may go back to at some point. And we re-estimated all the models in DaySim. I'm not going to go into much detail there, but just say what some of the key changes are. And then again, we'll give an overview of model calibration validation process. I can answer questions that come up in the chat. So let's see, why is that? Okay, there it goes. So the main, some things about the 2018 survey. I don't know if many of you have used this data yet. So as most of our RSG surveys, we used address-based sampling, which is sort of the main probability-based way of doing sampling for travel surveys these days. We use geographic oversampling of low-income areas and areas with high commute mode shares for non-auto modes, transit, walk, and bike, and TNC. That was using ACS block group level data. We actually got a lot of bike trips in the survey, so much so that we were asked to use this data for to do a bike model for Salt Lake City, which we can also share with you guys at some point to show you what they did with it. But they're doing their own Utah statewide survey this year, so I think they'll use their own data after they have that. But there is a lot of data for biking, walking, transit, all the different modes. So we used our smartphone app for 7 days for households where all adults had smartphones. And other households did a more traditional diary-based online survey for just 1 weekday, but with all the same questions asked. So the two methods give pretty much the same data, just the smartphone-based has more accurate data on times and locations because the phone is recording that rather than people having to go back and recall it. For people who are doing the diary-based method who didn't want to do it online, they could call in and to a telephone call center, and the people at the call center were using the same software that the people who entered it online would use. So it gave the same data format. So overall, there were over 4,000 households in the survey, most of them completing by smartphone. The smartphone data had an average of over 5 complete days per household versus 1 day with a diary-based. And because the smartphone data doesn't really rely on people remembering their trips, and it doesn't leave out trips that people doing the diary-based method might forget about some trips or just think, well, it's not important. They don't want to know about that trip. So we get an average of about 20 more trips per day in the smartphone-based data compared to the diary-based. So a lot less non-response bias. And in our weighting methods, we adjusted for that as much as we could in the diary-based data, give higher trip weights and higher weights to people who reported at least 1 trip during the day. What you find in the diary-based data,
you know that the transportation committee is going to be against this because they're all in bed with the
okay, somebody needs to be on mute there. Okay. So in the diary-based data, we find a lot of higher percentage of people who report no trips, which could just be like what we call a soft non-response. People wanted to fill out the survey because they said they would, but the easiest way to fill out the survey online is just to say I didn't make any trips, even if they did. But with the smartphone, it's a lot harder to do that because it actually records your trips while you're traveling, and then it's pretty easy to fill it in. Most people enter their trip details within a few hours of making the trip instead of waiting till the end of the day to report them all. So it's the kind of thing you can do while you're waiting in line at the coffee shop or the store or wherever. So in total, there were almost 190,000 trips in the smartphone-based data versus 6,300 in the diary-based. So most of the trip data and tour data is from the smartphone-based. And some of that's on weekends, which we didn't use in the modeling. So we did some further data processing. I'm not going to go into a lot of detail on this. I'll start with the main steps. We had redone the weighting developing some new methods and research that we did for the 4 main California MPOs to adjust for the non-response biases, which I was talking about. And we find that people who use transit and bike especially are more likely to respond to travel surveys than the average person. I think it's because their travel, is more affected by travel policy in the MPO and in the county and the cities. So they're just more engaged with transportation policy on average. And so we tend to get higher response rates. And if we don't adjust for that, we get mode shares that are too high for transit and bikes. So we adjust for that comparing to census data. We have some new activity purpose imputation logic that we developed based on other surveys. Just correcting things like if the phone says somebody's at home, but they don't give their purpose as home, or if the phone says somebody's not at home and they give their purpose as home. We have some rules to kind of figure out what they were doing, most likely doing there. And since the survey, we've actually added some questions to try to catch these things real time during the survey and have people provide their own corrections. But since the survey was done in 2018, we had to go back after the fact and impute some of the purpose imputation. And then we would select the household days for use in modeling, which were just weekdays with pretty full day patterns, which the model assumes, and then reprocess the data into format for that DaySim likes. And we went back to the parcel IDs. Parcels are pretty small in lots of cases, and the locations in the survey aren't always perfect, the geocodes. So that's a check to make sure that the survey, the land use in the parcel data is as consistent as possible with what the person said they were doing there. So if they said they were going to school, ideally you want them to be going to a parcel where there is a school, that sort of thing. I'm not going to go into all this in detail. That's just a summary of the trip imputation results. We have all these different rules for changing things. Most of the data is okay as is. A lot of this is just where people didn't answer a question, and we don't use that data in the modeling anyway. So these ones down at the end where there were missing purposes, and we try to impute them based on what other people did at the same what they did at the same similar location, or what other people did. But that last part doesn't affect the modeling too much, because for model estimation, we really only use people who have complete data for the day, where they didn't leave any questions blank. So, as I said, when we select the days for use in modeling, they have to be complete household days. So for all the people in the household completed all their trip surveys. For the R-Move data, where we had up to 7 days per week, we only included Monday to Thursday as typical weekdays. Friday tends to have a lot more travel than other weekdays, especially in the evening hours. So we decided to leave Friday out of the modeling. So you see these types of days here in the table are days where either people had no trips and they stayed home, but it looks like a valid day. days, we want days where people start and end their day at home within the region, because the DaySim model doesn't predict people leaving the region. And then there's days where people start and end away from home, start or end the day away from home. People where they leave the region during the day and then come back, or they do both. They start and end or end away from home and leave the region. So before the data processing, we would really only use these first two in the these first two rows in the models. And you see for our move data, we're losing more days before we did the imputation, because we had a lot of cases where it didn't look like people didn't report ending their day at home, even though the data showed that they did end their day at home. So when we corrected that down in the second table after the imputation, we got a lot more valid cases in these green cells where people did start and end their day in the region, where it's ended up pretty similar for the R move data, the smartphone data and the diary data. But as you see, there still are a lot more days where people, this is unweighted data here, so there still are a lot more days where the smartphone says only 12% of people stayed home all day, person weekdays on Monday through Thursday, whereas the diary data, we got 23% making no trips, staying home all day. Part of that's due to demographics, because the people who answer by smartphone tend to be younger and more active in general than the people who who don't have smartphones. And but a lot of it was due to bias. So, and we actually corrected for some of that bias in the modeling itself, which I'll talk about. And the parcels, the last part I talked about was just moving parcels around. So we have tests for each purpose that say, does the land use at the parcel match the test? And so for the wide majority of these, the first in the first four rows, the nearest, either the parcel that's in the data or the nearest one to that geocode match the test, either the first test, which is more strict, or the second one. So for school, the first test might be for college that there's actually a university there. The second test might be there's either a university or education employment on the parcel, things like that. So and if they don't pass that test, we try to see if there's another parcel within 1/8 of a mile that does, and we can move the survey we can move the parcel and change the parcel in the data to something that matches the land use better, because we're not sure that we have the precise geocodes in the data. It seems more likely that they actually went to the parcel where they could do what they said they did, if you believe the parcel data. So in these green ones is ones where we actually changed things. That leaves this small percentage in the yellow, or in these last rows, where it didn't really agree with the land use data didn't really agree with the purpose that's in the data, but we didn't change it. And that was mostly for K through 12, for kids who were like in preschool age, where where a lot of times the schools are in people's houses or the preschools. They're not really registered as schools in the parcel data. So that we probably should have split out by age here, K-12, kids under 5 and kids over 5, but we didn't do that. So anyway, that's really all I'll talk about for the data processing. I can answer more questions about that. I'll talk about the new work at home model. So DaySim already modeled people whose only workplace is at home. Like even before COVID, I always worked out of a home office. So I would be one of those people who would report in the census that I always worked from home, or in the ACS data. But increasingly, there are people who do have out of home offices who choose to work at home on some days instead of commuting to work. And this was already increasing before the pandemic, but it really increased a lot during the pandemic and will probably remain higher than it was back in 2018 after the pandemic. A lot more people shifting to hybrid work type schedules. So in the 2018 survey, we asked every adult how many hours they spent doing paid work from home for every survey day, whether they had traveled to work or not that day. So for DaySim, we added a binary choice model for workers who do have an out-of-home workplace. And it just says, does the person work at home that day for more than 2.5 hours during the day or not? And I'll show you in a minute why we picked 2.5 hours. And then we have this individual day pattern model, one of the core models of DaySim, which kind of jointly predicts how many tours and stops people make for different purposes during the day. So if they work from home, they have a lot less chance of commuting to work, maybe more chance of doing some other things instead of commuting to work. So we added new variables to the day pattern model, conditional on this choice of whether they worked at home during the day or not. So people can do both. They can work at home and commute to work. And a lot of people do actually do that, or at least they did before the pandemic and probably will again. So this is an analysis of the survey data. So based on how many hours they worked at home during the day, from 0 up to 10, what fraction of those commuted to their usual workplace that day? This is just for workers who have an out-of-home workplace, because that's who the model's applied to. You can see up to 2 hours, most people still commute to work, even though they do some work at home. But with 3 hours or more worked at home, only about 1/3 of people are commuting to work. And that stays pretty steady across these groups. So even 25% of the people who said they worked at home for 10 hours also said they went into the office that day. They probably didn't go in for very long if they worked at home for 10 hours, but we're really only interested in whether they had a commute tour. So when we estimated the model, the survey didn't ask industry type for each worker in the survey data. We probably should ask that in the next survey since it's getting so important for teleworking. But what we do have is the mix of employment at the worker's usual work parcel by type, 9 different types. So by that, you can sort of impute what type of job they probably have. If they say they work at a parcel and there's only retail jobs at that parcel, then they probably work at a store, that kind of thing. Or if there's only medical jobs, they probably work in the medical industry. So we interacted the fraction of jobs at their work parcel of different types with higher and lower incomes, kind of reflecting the fact that at least in some industries, people with the higher incomes usually have more flexibility to telework than people with lower incomes, like in office jobs, government jobs. Less so in medical jobs, because most of those people have to be at their jobs and they have a lower probability of staying at home. For like retail and food jobs, income didn't matter much. They usually have a lower probability of staying at home. But for something like office jobs, the higher income people have more probability of working from home than the average person, while lower income have less probability. So these are coefficients that can be adjusted over time to reflect different teleworking scenarios, what you think is going to happen in different industries in the future. So the main things we did in re-estimating the models are, there's different ways you can change choice models in SACSIM, the DaySim choice models. The easiest one, which Nagender is going to be talking about, is just editing the model coefficient files. You can use any text editor for that. And we have some automated ways of saying how you should do that to match calibration data. To fully re-estimate the coefficients of a model, you have to do what we did in this project, which was to prepare the survey data in DaySim format with a lot of QA, QC if you're going to quality control, if you're going to do model estimation. And then DaySim has an estimation mode where when you run DaySim for a model, it creates estimation input files for the Logit estimation software package. And then it pretty much automates it, so you can just run Logit without changing very much. And to run DaySim in this way, you can either do it from the DOS command line, so you don't have to get into the code at all, or you can get into the code with the C# integrated development environment, which is from Microsoft. And then you run Logit to estimate the model. Now, if you want to actually change the specification of the model, like add variables, change how variables are specified, then you actually have to change the code. So then you have to do it within the Visual C+, C# environment. So usually RSG people are the only ones who go this far in changing the models, but there are a couple of, I think some folks at PSRC have done some of this kind of work. You know, a lot of DaySim users in the future are going to be switching over to ActivitySim, which is kind of the next generation of models. And one way that's easier to use is that you can change how models are specified or defined without going into the code. So it has kind of a language that is run from spreadsheets that defines how a model works. So the key changes we made in the models, in mode choice, we use the generalized time, which is takes the relative, where you assert a value of time distribution, you assert relative values of time for like in-vehicle time, walk time, wait time. Because most survey data doesn't really support the estimation of those coefficients, as well as all the hundreds of mode choice models that have been estimated in the past. And we actually did a federal study, the SHARP2CO4 project, which recommended how to do these generalized time and cost coefficients. So we basically use the formulations that come from that report. And we were able to really, because we had more data, and I think more accurate data, we could get a lot better estimates of those coefficients, like closer to what we expected them to be, and a lot more significantly statistically significant. We added in the TNC taxi mode, which was asserted coefficients before. Now we could actually estimate them based on the data. Even though there weren't a lot of TNC tours or trips, there were enough to get some significant coefficients there. As I mentioned, the individual day pattern model was we added a lot of new variables to use the results of the new work at home model. So if a person does work from home, how does that change their likelihood of doing other types of tours and stops during the day? So they're less likely to commute to work, but they're more likely to make short tours from home for things like shopping, recreation, less likely to make intermediate stops, because a lot of times people make those types of complex tours as part of their work tours where they make a lot of stops on the way home from work. So now instead of going shopping on the way home from work, if somebody's working at home, they're more likely to just go out to the store from home during the day and then come back. Okay, so we did add some new variables for the work from home, where people always work from home, which is part of the workplace location model. And based on land use, we managed to locate those people a little bit more add some variables that get them located a little more accurately. A lot of times those people are in places that aren't real urban or not real rural. They're kind of suburban, but with pretty good accessibility to shopping and things like that, which is kind of the most convenient place to live if you're going to work from home all the time. Okay, that's all I have. Do you want to ask questions now, or let Nagendra do this part and then ask questions afterwards? Either way is fine with me.
Hi, Mark. Thank you for your presentation. If anybody has a question, feel free to drop it in the chat, or if you'd like, you can unmute and ask the question directly. Maybe we'll give them a second. Some people might be typing, but if you'd like, you can stop sharing your screen. And
yeah, well, let Nagendra go and I can answer some after he's done, if there are any.
Mark, if you could stop sharing, then I can start sharing my screen. Okay, great. Thank you. All right. Can everyone see my screen?
yes, we can.
Great. Should I start or should we wait for people to?
It doesn't look like we have any questions, so feel free to start. Thank you.
Okay, great. All right. Hello, everyone. So my name is Nagendra Thakur. Mark and I work on this project in the last few months. And Mark went through the estimation process and the new model that we implemented in DaySim set of models. In my slides, I'm going to describe how we did the calibration and validation of the newly estimated model. And just to give a quick summary, what we did is we had a set of R scripts, which we call the calibration tool. We use that to generate various summaries that we typically use for our calibration. And then the idea behind doing the calibration is to just remove some biases that may have been working during the estimation process. And it's just the calibration validation process is an iterative process. And I'll talk more about it in my next few slides. So with this, I'll start with my favorite slide, which I typically use whenever I talk about a model development. It's an iterative process. And before I describe this iterative process, I also want to define the different terms we typically use in model development. One is the estimation, which Mark talked about, and that's where we use the raw data, estimate the coefficients that go into the utility functions of a model. And then the calibration. Calibration is just adjusting those new coefficients that were re-estimated and make sure that they match with the summaries that we typically compare model work with the survey. And then the validation is a typical term that we use to look at the assignment results, whether it's the vehicle flows, the auto flows, or it's the transit boarding and all other things. And that also includes looking at the VMT or any other results that you typically use in your process. And then we also do some application test and some sensitivity testing of the model just to make sure that the model, the newly estimated model, is sensitive enough to the different inputs in the model. And all that is an iterative process. You start estimating the model, you calibrate it, validate it, and then you kind of look at the effect of one step onto the other one. And then you may need to go back to the calibration again or validation and start adjusting your model again to finally have, after a few rounds of this, have a model which you are more satisfied with. So there are many benefits of going through this iterative process of everything, calibration, validation, testing, and again, start from there. The benefits are, while you're going through this iteration, in the initial iteration itself, you will know and if there are any weaknesses in the model, if there are any bugs that were introduced, if there are any major issues, and that you can quickly fix in the initial rounds. And then the other benefit is, that way you manage your resources on the project very effectively because you have already identified the issues and fixed in the beginning. And then later on, you can start doing the same thing and then fix and matching the model more closely with the survey data. And that is also another way to get your staff more involved in the process, because in every iteration, there are technical discussions, what went wrong, why it went wrong, and your staff is more involved with it. So this is something that we typically use, and I think there are more benefits of using this approach in a typical model development project. Before I go more into the actual calibration validation process that we typically use, I also want to introduce briefly a few things. For example, the DaySim activity-based model, which is what I'm mainly going to talk about for my calibration process. So here is a simple flow diagram of the different model components we have in DaySim. And you can categorize those in two sets. One is the long-term choice, which are mostly at the household level, where you have the work location choice, where you determine where every worker works in the modeling region. Then the same school location choice, you have the auto ownership, how many vehicles are owned by every household. And then once the long-term choice is run, then you have the short-term choices, which are more at the individual day level. And there are different submodels within that category. I'm not going to go deeper into this, but I also want to briefly describe how an entire model system typically consists of and how DaySim fits into that system. So typically is there any question, or I think someone needs to mute themselves? Okay, so I'll go ahead. So there are typically, you have a set of inputs that includes land use data, synthetic population, and the network systems, which defines the level of services in terms of the distance between OD pairs, travel time, transit fare, or any other level of services that are being used. That go into demand models. And one of the major demand models is the DaySim, which simulates travel for the residents in the modeling region. And then beyond that, there are also other demand components like the internal external model, or there could be an airport model, or there could be a truck model. So all those I have put into the auxiliary demand model components. Both the outputs from the DaySim, which are usually triplist form, and the demand from the auxiliary model, they are put together, and the cube matrices, which is basically the software that we are using for the SACSIM model. So I'm using the cube software term there. So they are put into the cube matrices form, and then they are assigned on a network. Once those are assigned on the network, you get vehicle flows, whether it's the auto flows or transit boardings. They are again fed back into the demand models, and this is what we call a feedback loop. So that way, once you have the new assigned flows, based on those, you will recalculate your network skills, the level of service variables, and then they again go back into the demand models, whether it's a DaySim or any other auxiliary demand. Demand is recalculated, you again go through the same thing. You create the assignment matrices, assign them. And this feedback loop goes on until you reach a convergence criteria, depending on the threshold that you have put into, or if you have determined that, okay, no matter what, we're going to do only 3 feedbacks. And once that is done, you are done with your model system, then the post process kicks in, and that's where you generate various set of summaries for the assignment flows. So that's a typical process. And one other thing I also want to briefly describe is how we typically calibrate a Logit model. What are the coefficients or the variables that we typically adjust? So for a Logit model, generally it's in this form, as you see on your screen. It's the exponential of the utility function, which is U term here, and probability of choosing a choice in that is calculated in this form. And here, the utility takes the form of having a deterministic component and a unknown or non-deterministic component, basically. So U here, the first term in this equation is the deterministic, where you have your coefficients interacted with different variables, and that's what we estimated in the estimation process. And also we have the non-deterministic, which is where we focus more on the calibration part. And again, this non-deterministic is also estimated during the estimation process, but we try not to touch much on the deterministic unless we have to adjust more variable specific coefficients. So typically we adjust or change the constant, which is the non-deterministic, and this is given the form of the probability function in the beginning. What we do is we take the ratio of the observed value and the model value, which is the estimated value, and then we take the exponential, not exponential, the natural log of that ratio, and that is what is the new adjustment for our next iteration of the calibration. So if you put that into an equation, then the natural log of the ratio between observed and the estimated value is added on top of the existing constant you have in your utility equation or in your coefficient files. Sometimes, depending on how sensitive the model is, you may also have to put a damp factor to that adjustment, which is the natural log of the ratio. And it could be, typically it is less than when if your model is very sensitive to that, but it could also be greater than one if you want to quickly reach the match between model and the survey data. So with this, the other thing I also want to show is this is a typical format of the DaySim coefficient files. And here's an example of the work location choice coefficient file, where you have in the beginning, there's kind of some header, and then after a few lines, you see different columns containing some numbers. The first column here is the index, which we typically use to identify what is a coefficient. And then the fourth column is the actual coefficient value. And this is fourth column is the one that we change during the calibration process. For example, let's say the coefficient index number 6, which is row 9 here. So, you know, if depending on what you're trying to adjust, if your summaries are not matching, you will change the value of the index 6 in the fourth column to based on the calibration, the ratio and the natural log of the ratio. And by changing that, then you read on your model and see if that affects the model, the summaries from the model, and then how that compares with the new survey data summaries. So with that, I want to describe the typical model calibration process we have in-house that we have created. And it's not an entirely automated, it's largely automated. That means most of the steps are automated, but there are still 1 or 2 steps which requires manual intervention. To start with, you run the DaySim model with the initial set of inputs, whether it's the land use data, synthetic population files, the coefficients. And then once that is run, then you generate a set of summaries, which we have a R tool for that. Those are all automated again. It's all part of the batch file. In that batch file, we first run the DaySim, then we run the DaySim summaries, which are produced in a set of spreadsheet. And that spreadsheet also has an automated way of recalculating the adjustments for your next iteration based on the model results and how they compare with the survey data. So those are the new coefficients that are calculated within those summary spreadsheet, which are part of the DaySim summaries outputs. And once you have those new coefficients in those summaries, you copy those, and that is the manual part. You copy those new coefficients from those summaries and paste them manually in the DaySim coefficient file, and then again rerun the batch file for the next iteration. So that is the calibration process that we use in-house, and there are few things that you need to have that tool in place and start using it. One for sure is you need to have the model set up, where you have the DaySim set up and the different inputs that you use in your model. And this is the setup we have for the latest SACSIM model, where you have the DaySim folder, a separate folder for inputs, and then the last is where you have all your outputs produced for your scenario. And that does include a few inputs in there, but most of the files in there are the outputs from a model run. Then the next thing that you would need is a calibration tool that we call it. And that is something that we have prepared in-house. And that includes 3 primary components. One is there is a R tool that is used to generate the summaries using the DaySim outputs. And then we also introduced a workspace, which we call it as iterations. That is very useful to archive your files so that, you know, later, let's say after a few months, you want to look at how your previous calibration progressed, then you can go into this folder by different model components and start looking at how iteration 1 had the coefficient, what were the summaries at that point, and how, you know, let's say the iteration 10, how you went from iteration 2 to iteration 10. So all that is, every iteration is stored in that workspace, which I have found very useful to store your work and refer back when it's needed. The last component there is the batch file, which is very important. And that's where we have automated most of the calibration steps. And so to go more deeper into these 3 different files we have, one is the R tool, which we use to generate DaySim summaries. This is how it typically looks. And here the different components include, one is the observed data, which is typically in a household travel survey. And the second is the software, which is R executable, because we are using all the R scripts. So we already include that software as part of this DaySim summaries tool, so that you don't need to separately install it. And then there is also a folder where we have templates to generate spreadsheet summaries. And those templates define, at what sheet in the spreadsheet you need to put the outputs, and at what cell, what kind of summaries needs to be put. All that is defined in this templates folder. And then you have a bunch of R scripts to generate summaries by different model components. And there is also one main batch file that kicks off this DaySim R summaries tool. So once you run this, then the outputs are generated under the output folder. That's where you have all the spreadsheets by different model components, providing you the summaries from the model and also the summaries from the survey data, which is in the data folder. And there, everything is set up for calibration as well. And the typical summaries include, by different model components. Here is a list of that. I don't want to read through everything, but we have a comprehensive set of summaries in those spreadsheets. And depending on what we value more in those summaries during the calibration process, we try to adjust the coefficients based on those, and then look at the results. So here, the new work at home model that Mark added to DaySim is included as part of the work location choice model, even though the model itself is part of the individual day pattern. But to have all the work location related variables in one place, we have added that on the work at home summaries as part of that spreadsheet. Now, the workspace includes different folders for different model components that you want to calibrate in your calibration process. And so those are the 6 different models that we calibrated as part of this project. So I've shown only those 6, but there could be more. If you have to calibrate the time of day choice, you can have a folder for that. And that way you can store, or you can organize basically your calibration process in a more intuitive way. And it's very easy for you to look at and explore the process later on in the step. Then within each folder, there is always an initial setup requirement. And that includes, you need to have a batch file which automates the calibration process for that particular model component. And you also need to have an initial folder on the CR0 there. And here is an example of the work location choice model calibration, where you will have the work location underscore CR0, which so CR means the calibration round, and then the number there means the iteration number. So for iteration number 0, you need to have that folder, and there are initial set of files that you should be having that includes coefficient file and the shadow prices that we try to keep constant throughout the model folder, so that we keep all the inputs the same except the coefficients. Then once you have done the calibration, then your that work underscore location folder is going to look like this, where for every iteration you're going to have one folder, and all those folders will be created automatically. You don't, once you have created the initial setup that includes the CR0 folder and the batch file, every time you run the batch file for your calibration iteration, all new folders will be created in every iteration. And this is a good way to store your data, and I'll refer back to it later. And then the next thing is about the batch files. So we have different batch files for every model component. And here is a list of the 6 batch files that we have used as part of this project. And they are in the root directory of that particular model component archive folder. And just to give a quick look at what that batch file typically consists of, it's a simple batch file. It just automates different steps. And in the beginning, you have a documentation of it. I haven't shown it here, but when you look at the batch file, everything that is part of the batch file is basically described in the beginning, so that if you are confused about a few things, you can always look at the batch file and read about it. But typically what it includes is, in the beginning you have the different paths that you need to set in the beginning of your calibration. That includes the directory of your model setup, and then you also need to specify what is your DaySim directory within that, and where is your DaySim summaries tool located, and where you want to store all your iteration related files, which is the archive directory. Otherwise, everything else is all automated. You don't need to worry about it. In every iteration, you need to change the iteration number, which is line number 46 here. And initially, you're going to have it as 0. But as you progress in your calibration, you will increase by 1 every time. And the typical step of these batch files include what it does. First, it copies different inputs from the current iteration model, current iteration folder to the model folder where you are running DaySim. And then DaySim is run. Once DaySim is finished, then using those DaySim outputs, DaySim summaries are run. Next, the output from the DaySim summaries, which are spreadsheet formats, are copied from the DaySim summaries output folder to the archive space that we have created for that particular iteration. And then it also creates a new directory for the next iteration, which is going to be CR1 if you're running iteration number 0. And then it also copies the initial set of inputs, the coefficient files and shadow prices, to the new iteration folder, so that when you work on it, you have something to start with to update the files. Then the calibration process itself, just to refer back to the diagram that I showed a few slides ago, where we have an iteration process. You run DaySim, you run DaySim summaries, then calculate the new coefficient, update. So the way it is followed in our calibration process, you will start with the batch file, so that's where you have everything. And if you're doing your the first round of iteration, then you will have the iteration number in that batch file set to 0. You will run it with everything the same as you had in your model. You run it, it is going to run the DaySim, it is going to generate DaySim summaries, and everything will create the folder for the next iteration. Then what you will do is you will go to the folder of the current iteration, which is CR0, open the summary spreadsheet, which will be copied from the DaySim summaries by the batch file. You open that, look at it, and calculate. There could be in every spreadsheet, there could be multiple tables recalculating coefficients depending on what you want to recalculate. In that round, you can enable that. There is a damp value, which basically specifies whether you want to enable or disable the calculations for the new round of the coefficients. Those are calculated automatically once you have enabled it, and then you copy the new coefficients from that spreadsheet into the coefficient of the next round, which is under CR1. You paste that into the coefficient file, go back to the batch file, change the iteration number to increase by 1. In our case, let's say if you're starting from 0, then you will make it 1, and then again run the batch file. Once you have run the batch file, it will finish generating those DaySim and DaySim summaries. Then again, you have to start from the iterative process. Look at the summary spreadsheet in CR1, calculate new coefficients by enabling, disabling the damp factor, and copy those coefficients into the coefficient file, go to the batch file, increase your iteration number by 1, run the batch file. This process is followed until you are satisfied with the summaries of your model versus the survey data. So this is all we use, and I think I have used up all the time, so I wouldn't go into a live demo, which I was thinking I will do if we have time, but I'll stop here and I'll let you guys ask any questions to Mark or I.
Thank you so much. We do have a question in the chat. Is this going to dramatically increase the amount of storage a run will take on a machine with all of the iteration folders? Can you give us an idea of the magnitude of drive storage for a typical existing year and cumulative year run?
So yeah, I think I can answer the first question. So the archive folder, and I think let me share my screen. It is going to not take much space. It includes only a few files that are very small in size. For example, I'll show you the work location, right? And I think let me show you this where I did all the iteration rounds. So you'll see that under CR0, you have only these few files. One is the spreadsheet, and these are very small in size, except the shadow price, which is 50 MB. Otherwise, these are like 3 MB is the park and ride shadow price. This is the main shadow price, which is 50 MB, the 50 MB. Otherwise, the coefficient file is very tiny, and even the spreadsheet is like only 260 kilobyte. So with this, if you look at the size of this, the work location right here, after 14 rounds of iteration, it is only 800 megabyte, and majority of it is because of the shadow price. But I feel that this is worth keeping it because that way you know how your iteration went from starting 0 to 14. And if you have to look back and see, I may be seeing some issues in my calibration round and I want to identify where things went wrong. You can always go back and trace back your steps. You can go to iteration 8 and see if that looked correct or not. So I don't think it's a major impact on the disk space by storing the calibration rounds, but I do think it does provide you benefits, a lot of benefits for later in future.
Thank you.
I can clarify maybe one thing, that the model estimation works on unweighted data from the survey, and it uses as much data as we can for any given model. So any survey respondents that have valid data for estimating that particular model. The calibration works with weighted data. So more like what you would, where the weights are made, we make sure the weights match those in the synthetic population, so that the model output running on the whole synthetic population should match the weighted data as closely as possible. And the weighted data only that's put into calibration only includes full household days that are match the same sort of criteria that in the days that household days that DaySim simulates. So staying in the beginning, ending at home, things like that. And a reason why, to give an example, that in the Seattle region, for instance, the cities, three adjacent cities, Bellevue, Redmond, and Kirkland, BRK, decided to do their own subversion of the regional model. So rather than re-estimate the whole model system, they just recalibrated it to their finer zone system for that subregion. Also, in things like that, you can change your synthetic population so that you only subsample on counties that are far from parts of the region that are a long way from your subregion, because they don't really matter too much to your part of the region. So it runs faster. So you can put different expansion factors on different parts of your synthetic population. I think we have a new project there where just Pierce County is doing their own subregion version of the model. And also for some regions, I think including the Bellevue region and Fresno, we've done calibrated their model for future work at home scenarios, telecommute scenarios. And the idea is that this new work at home model will make it easier to do that kind of calibration. I don't know if you have anything to add to that, Nagendra. Yes,
I think that's all for that.
Thank you.
And I have a hard stop. I need to go to another meeting. So if there are no more questions, I would drop off.
There are more questions, but I think the next ones could be answered by Mark potentially. There's only
Okay.
2 more if you're
Yeah, I can still stay for a few more minutes. Yeah.
Thank you so much. We'll make this quick. How many of these processes will need to run regularly for a typical run?
I can answer. Yeah, Mark,
you could probably do that one, Nagendra.
okay. So so in the calibration, and depending on how of your some output DaySim outputs are from the survey data, it typically depends more on the model, submodel as well. Like the long-term choices don't typically take too long, but also sometimes when you go through every iteration, you find some issues that, okay, I made this change, maybe it's not moving in the right direction. And then you kind of, try adjusting maybe the survey data itself. You think that, okay, this is not looking right. I think the survey data could be higher or lower. And, but adjusting the model to the survey data itself should be very, few rounds, and could be like on average, I would say 5 or 6 rounds, but typically it takes longer because as you're doing iterations, you find stuff, whether it's in the model or it's in the survey data itself, and then those 5 iterations goes to like 10 iterations sometimes, or 15 iterations that way. But yeah, I think I would say somewhere between 5 to 10 is usually enough for you to achieve the model summaries to match the survey summaries.
Thank you. The next question could be opened up to Mark as well. We've long been good at calibrating mode shares and transit riderships by adjusting constants as described, but tend to get excessively short transit trip lengths. I've suspected this to result from the same coefficient for in-vehicle time for cars as transit, a common orthodoxy. Any progress on this front? This is too in the weeds. We can later as well.
I think you could also change boarding penalties. Which might not just transfers, but also for initial boardings to that would probably reduce short trips, I would guess. Yeah, I think most models still use the same in-vehicle coefficients for cars as transit. I think you can assume a different coefficient for transit in vehicle time that relative to car in DaySim, but I don't think we usually don't estimate them separately, partly because from revealed preference data, it's just really hard to estimate things like that very accurately. People do it from stated preference data, but then there's also a question of how realistic that is. So.
Thank you, Mark. Nagendra, did you have anything to add to that?
No, I think that sounds good to me as well. And I believe you would need to basically look at these different penalties, the initial boardings, and that could also be done at the assignment level if you want to do that. But there are many path impedance related variables we have in the DaySim properties file where you can play with it. And then we have these accessibilities to transit, and that would also play a role there. Yeah, I think it's again, this calibration process is kind of an art in a sense that you need to understand how everything interacts and what needs to be changed, and you would probably need to sometime try different things to see if you are getting desired results. And it's again, the combination of calibration and the validation process.
Yeah, it also struck me that it would be possible to totally automate this whole iterative process by having, the program copy the coefficients over and do the iterations. But I don't know if that's a good idea, because you definitely want to look at what's going on, and it takes also some judgment. But if to see what the calibration is doing and whether it might be a problem in some of the data rather than the models and things like that.
Yeah, and we do have an initial version of an automated calibration process where we have been copying the coefficients into the coefficient files, but that is again, still in the initial stage. And as Mark suggested, it's always recommended to look into your results in every round and make sure that the model numbers are moving in the right direction. And it's a judgment call sometimes. So, but yeah, having an entirely automated process helps when you are initially satisfied that, okay, the changes that you are making are going in the right direction. So you can simply do 5 iterations of the same without manually updating stuff in every iteration. So that is still happening. We are doing that as part of a different project. But again, as of now, this is the process we have. And as we do more things, we'll be automating it further and improving it further.
Thank you. And that's all the questions in the chat. If there's any other questions, feel free to unmute yourself. It looks like we're all good. Nagendra, thank you so much for joining us today. We really appreciate it.
Great, thank
You
you.
as well, Mark.
Bye.
Hey,
Bye.
thank you.
Thank you, Mark. And then Nagendra.
Yeah.
Before I hand the mic back over to Kyle to close off our presentation, I wanted to plug our exit survey one more time. Thank you so much all for participating. And if you could let us know what you thought of yesterday or today's presentation, or presentations, I should say, that would be fantastic. And let us know how we can improve for next time. I'll plug that in the chat right now, and I'll hand that back over to Kyle.
Thanks, Hannah. All right, so if this last part of our user conference is the beta test group. So if you do not want to participate in the beta test group, feel free to drop off, but definitely you're welcome to stay and join us. And thanks for participating. And please fill out the user survey that Hannah posted in the link. We really do take those seriously. All right, can everyone see my screen?
Yes, we can.
Great. So some of you may have been around in the 2018 conference. And if you recall then, that was our first annual conference, and we had a beta test group of SACSIM23. That model in particular incorporated some TNC and AV testing, as well as pricing. And so we were able to put a beta test group together to provide feedback on that before the adoption of that model, which again is in the 4-year cycle with an adoption from our plan. So the feedback from that beta test group was incorporated into SACSIM19. All that being said, this is the opportunity to be part of the beta test group for SACSIM23. We are actually releasing this even earlier in our plan cycle than previously. So some of the items are very much still being developed, but wanted to provide this opportunity before we started forecasting our blueprint pathways. So we have a web page up. That's what I have on the screen here. We will be adding information as needed to the web page, as well as a link that it should be up. If it's not up now, it should be up on the web page this afternoon. But we are requiring a confidential non-disclosure agreement to participate in this beta test group. This is the same language as it was 4 years ago. It asks that these files are beta. They are not ready for project use, and any findings, please be sent back to SACOG staff. So for this beta test session, we are proposing a 1-month testing period. And at the end of that month, which is about 1 month, July 15th, we would request any beta testers to provide that feedback at that time. Some previous beta testers provided this in a memo form. Others provided a summary of findings in just an email. Either is sufficient, and we'd ask that for those of you that have multiple users per organization to please consolidate your findings and provide in one format. We realize that everyone has busy schedules, and so if this 1 month is not sufficient time to finish all of your testing and findings, please send us an email on a one-on-one basis if you need an extension. But we'd really like to provide this time as the time that SACOG staff are willing to have the time and resources to support this test group. So what that means is if you during this have questions on how to set up the model, changes, how to run it, some of the calibration information that was just described by RSG, SACOG staff and Shengyi and Yame and I specifically are willing to put resources to help you out during this time. If you need extra after this 1 month testing, we simply just don't have enough bandwidth to extend that, and we won't be able to provide as much support. That's in the timing of probably our most busy time forecasting and building the pathways for the MTP blueprint. So just want to be transparent that that this is trying to be fit in a very tight time frame, and so I'd encourage you to reserve some time to do your testing sooner than later. As I mentioned, a few of us will be helping out depending on what the questions are. And so please direct all your questions directly to SACSIM@sacog.org, and we will respond accordingly. So, so far in the event group, the question is, who is this beta test group? And we have 32 participants, which is, I believe, more than last time. I think we were a little under 20 and 14 organizations. And so we were at 10. So really happy about that participation. And if you did not sign up for the beta test group, but would like to, please reach out to us as soon as possible. And we will be able to put you on there, provided you sign the user agreement. So what the files are that are going to be specifically in this, what we're calling the beta SACSIM23 files, this is, we are still working on the calibration. So to be clear, this is not a MTP SCS scenario. This is a beta file test. Currently, the details of those files is we're working with previous SACSIM 2016 year land use, and the new files are calibrated to the 2018 household travel survey. So that is what we are able to share, and we can provide these additional scripts. So this is really an opportunity to get familiar with the new format. This includes the new TAZ structure that was described yesterday, as well as the new network interface and some of the additional speed testing that we've done. There's some other files that are updated. I think one specifically is the gateways have an additional gateway, 2 gateways actually. And so there are files that I'm not mentioning here but they will be included in this beta test. And if there's any questions on what those are or need further clarification, I'm happy to answer that in follow-up correspondence. So we anticipate, I said 1 month, and I believe I put July 15th. So we anticipate to have these files ready on SACOG SharePoint by Monday. As I mentioned, we're still working on the calibration on our end. And so what Nagendra just described, Shengyi has been going through this process, and we continue to test and retest and check against different sources that we have available. I think the only other thing I wanted to note on here was the change in the folder structure. So the scenario run folder is the same. So you will still run the SACSIM script in order to run the full SACSIM model, but the DaySim folder is slightly different. It's basically been organized into these 2 separate folders, and so the coefficient files that were described in the last presentation by Nagendra now have their own folder, so they should be just a little more organized to pull out and review. I think that's all I have. Shengyi or Youngmei, do you have anything you want to add?
No, I don't have anything to add.
Yeah, I'm good too. But there's a question from Jimmy in the chat.
Jimmy would like to know, for this specific beta test file package, could you also provide the output files or just the key output files so that we can test running the model and check if we are reproducing the same results?
Yeah, I think we can create an output file, no problem. I think that the DayNet, is that sufficient, Jimmy, or do you have other files like the SCIM files that you're looking for?
Yeah, I think definitely the DayNet, like the assigned networks, matrices would be, some of the final like output matrices would be helpful as well. And then even like the one, I know it's large, but the person trip file would be helpful.
Okay, yeah, that's helpful. Obviously, you know that all the files is just a lot.
Yeah.
So if there's particular files, we can just continue to add those on a one-off basis to the shared folder, which everyone will have access to once you sign the beta test agreement. I believe that it's been about a year, we migrated away from the FTP site, so that no longer exists, but we do have a SharePoint that we are able to share external files on, and we will send that to you once we receive the signed beta test agreement, and we will continue to add files there as needed.
Hey, Kyle, I'm not sure if I missed you saying, but I know, last time you were wanting to focus the beta test on, the AV side of things and the pricing side of things. Are there particular, this time, is it more just testing it on being able to use it and usage, or are there particular processes and particular outputs that you're more wanting to look at?
So from my end, I think the big changes is the TAZ structure, the network inputs, and then the re-estimation and recalibration of DaySim. So really, how is the model performing as you'd expect it? Is there further calibration we should do before forecasting? Those are really it. And then we're also just trying to share with the user community what these changes are in advance, so you can get familiar with using the new tool before the adoption time frame. Shingy mentioned,
like,
yes. Sorry,
yeah,
go
so
ahead.
it sounds like this is a little more general, potentially general usability than, you know, specifically looking at, you know, at some of the certain modules that you were really focusing on last time. That's right.
To be clear, the pricing functionality is incorporated in this. It's the same as SACSIM19, but any feedback changes based on our new you know, estimation or coefficients, feel free to, you know, you're welcome to provide feedback on any particular part that you're interested in. I think the new features are, as they mentioned, the TNC deadheading and having a new additional mode specifically for that, so its own curve function, and having the telework functionality. Shingy, am I missing anything else that's new from SACSIM19 to 23?
No. So yeah, so totally agree with what you just said. So I recall during the last beta test, the report, so some of you just found incorrect the coding of in network. So this time, so we do hope, you know, we can just use your intelligence to find the incorrect coding in TZs and the network. As some of you pointed out yesterday, you know, the sum centroids was connected to the interactions directly. So we do hope you can just find those kind of, you know, questionable the coding. And so we have the new module in the data hiding calculation. So based on the memo of and the new DaySim memo, so you will find how it was coded, and you will see that part in the SACSIM code. So just please review if it is, you know, how good it is from your perspective, and then you can run the summary to say if it is that what I expected. I will also include the summary tool within the run folder. So just please change the path of the CMD files in the summary tool, so that you can run the summary. Once you have a full model run, you can see, you know, if that's what I expected results from your end. Those kind of things. It's as we just said, is very broad, not a specific task. So we try to do our due diligence, but we do hope, you know, we can just make use of your eyes and the minds to find more. We have not found it yet.
I had one more.
Thanks.
Thank you. I had one more question. Is any of the population synthesis processes going to be included within this beta test and files?
So that's a good question, Jimmy. Currently, we're still working through developing the 2020 population. I think what we can do is, as Ibrahim mentioned, he's developed some scripts to pull directly from the census API and then convert to the population SIM format. So we should be able to share some of that, and we can share more as we continue to develop those files. But currently, they're just not quite ready.
Just
Thanks.
one more comment for the new DaySim, we did made a little bit of change about the number of workers based on the person type. So based on our latest analysis, we found a lot of people who are 65 years older. Some of them to work part-time or full-time. And then a lot of students work as either full-time or part-time. So we did change that definition of the student workers and then quote retiree workers. So you will see there are more workers in the file you will receive than what you used to in the past.
And one more thing, kind of just on that note, is there at least like a correspondence file outlining kind of any of the new outputs or like groupings for things like age and other metrics? Just in case we need some resource. I know like you'll be working on documentation updates later, but for our purposes of testing this new model, if there's any documentation or user guide that we can follow.
Yeah, so we don't have that yet. That we do, as Shingy mentioned, have the DaySim re-estimation memo from RSG. So there should be some of those changes described in there. I'm happy to share the changes that we did and then the comparison between populations, person types, if that's helpful, Jimmy. But we're still working on that development on our side as well. But we can share some of those differences.
Okay, thank you.
All right, well, and if there's no other questions, I want to formally thank you all for participating in this user conference, but also really in this beta test group. As you know, we have a lot of regulatory restrictions and a lot of work to do in the plan. And so this is really the best time for us to incorporate any comments on the model development specifically. So really, really appreciate your time on this, and looking forward to hearing all your feedback.
Thank you.
Thank you.
Great, thank you. And I will send a follow-up email specifically to the beta test group.
Thank you.
Okay,
Bye.
thank you, everyone.
Yeah,
Bye.
thanks everyone.
Thank you, everybody.
Thank you.
Okay, bye-bye.
Bye.